we will be covering number properties. So number properties is something we've covered in the past a little bit. I decided to kind of circle back to it today to do some stuff. Now, we may or may not do more number properties next week. We'll see how things go today. But what I want to focus on in this webinar is divisibility, and then maybe get into some LCM GCF. Now, one of the things with divisibility that we've gone through before is that a lot of divisibility is based on simplification, and I don't want you to get this mixed up with remainders. Simplifying through divisibility is a much different process than simplifying through remainders. Now, most of you guys here are using TTP, so you probably know all this, but if you're new to the webinars or you're new to TTP, go sign up for our 5-day trial. It's full access. Check out our number property stuff when this is over, and you can practice this. If you're currently using TTP, then continue to follow your study plan. We'll have plenty of time to chat about it at the end with some Q&A. So let's dive in. Now, when you guys get your answer, make sure you put it in the chat box, and then we will chat about it, and we can go from there. Now, one thing to mention here, evenly divisible by 7. So if x is a positive integer, is x evenly divisible by 7? That's what we're going for. As you know, it's data sufficiency, and we don't have the answer choices up, which is totally fine. So I'll give you guys a couple minutes, and then we'll chat about the answer here. I see a lot of correct answers here. Couple incorrect answers. Did you guys feel like this was on the easier side or harder side? Easy. Okay, that's good. Good. All right, so there's a couple different ways to deal with this. Obviously, we want to know if x over 7 is an integer. It kind of goes without saying, right? So what we have to do here is use our rules of fractions. Now, what are those rules? Well, you can distribute, right? And then what that gives you is 147 over 7 plus 2x over 7 is an integer. Now, 7 goes into 147 21 times. And then you have plus 2x over 7. So the question is, 7 doesn't divide into 2, or 2 doesn't divide 7, either way you want to say it. So what does x have to be? Well, x has to be a multiple of 7 in order for this to work. Could you confirm this by plugging in values like 7, 14, 21 for x? You could, but you really don't need to. So at this point, you could say statement 1 is sufficient. Moving on to statement 2, doing the same type of distribution of the denominators. After fully simplifying, you get 22 plus x is an integer. And then, of course, well, what can x be? Anything, 1, 2, 3, 4, 5, et cetera, et cetera, et cetera. Some of those values are divisible by 7. Some of them are not. Insufficient. The answer is A. All right, so that one wasn't too bad. Now I want to get into some harder ones here. So, well, I said x is a positive integer, so that's why it can't be what you just described. So x has to be a multiple of 7. All right, the next question, this is a little moved over, but if x and y are integers, is x, y, or x times y over 6 an integer? So this one's definitely a little bit harder. This is one that I've done a few different times with you guys. So for those of you who are new, it's new. For those of you who are not, it's probably not. So take a stab at this. I'll give you guys a few minutes again. All right, I see some answers rolling in here. Did you guys, I assume, based on the difference in answers, some of you found this harder and some of you found it easier than the last problem? Is that accurate? Okay, cool. So there's some good stuff that we can do here. The first thing I'll tell you is make sure that you don't miss the fact that this is the question. Now, if I'm looking here, anyone say A as an answer? I'm just kind of looking. I think somebody did say A, unless it was from the last question. I'm not sure. Now, if you said A, you probably said, of course, xy over 6 is an integer, because when you divide 6 into 96xy, it's an integer. The problem with that is that the question isn't about 96xy, it's about xy. So when you actually do the simplification, you get 16 times x times y is an integer. What does that tell you? It tells you that statement 1 basically gives you no information. In fact, it gives you the exact information you already knew from the given information. So I want you to tuck that away. There's something really important about that. And to reiterate, when I say that, I mean when the statement gives you the same information as the stem. So statement 2 now. 20xy over 7 is an integer. Well, in this particular instance, sorry, I'm just looking at the chat here. In this particular instance, 7xy is just a multiple of 7, right? Similar to the last question. And we can say xy over 7 is an integer. Okay, well, what does that tell us? Well, it tells us that there are values of x times y that could be divisible by 6, as somebody already said. 7 is a possible version that gives you an answer of no, but if x times y was 42, the answer here would be yes, right? And because of the yes-no answer, statement 2 is insufficient. Now, here's where the cool part comes in. I don't know what some of you guys did here, but when you look at this problem together, you may say to yourself, okay, well, now I have to take the information from both statements and I have to combine it. Well, you're not wrong about that. You do have to do that. But if you know that one statement is not producing anything of value, then there's nothing to combine. This is so big. Statement 1 gives you nothing of value except saying what you already knew, which is that x and y are integers. So there's nothing to combine when you look at these statements together. Statement 2 on its own doesn't work, so it's automatically going to be E. There's nothing more that you can actually analyze when bringing these statements together. Now, if you don't see that the way I'm saying it, well, think about this. Using both statements, could x times y still be 7, and could x times y still be 42? The answer to that is yes. And that's the exact information we got from statement 2. It doesn't change when you bring statement 1 into the mix. So the reason why I'm telling you guys this is so that you can save time, because the GMAT is all about saving time. And if every data sufficiency question, or let's just say there's like 3 data sufficiency questions in which you save yourself 30 seconds, okay, that's a total of 90 seconds, which is a minute and a half, which may be enough time to answer the one question at the end that you have to finish before the clock runs out. So you got to think about these things, and you got to be super strategic, because doing basically what I mentioned could be the difference between you getting a question right and not, essentially. Okay, one more. There's one more. Oops. We will move into now some LCM stuff. There's 2 questions I want to do with LCM, and then we can do some Q&A, okay? So now we're going to do a couple of least common multiple things. So I'll give you guys a few minutes, then we'll chat. All right, so a bunch of correct answers here. That's good to see. All right, this is purely an LCM question, okay? When we're saying that a number is divisible by two separate numbers, your mind should immediately go to LCM. The real question is, how are you going to get that LCM as quick as possible? If you go the prime factorization route, you see that 15 is 3 by 5, 24 is 8 by 3, which is 2 to the third times 3 to the 1. And as you know, when you do the LCM, you take the larger base of any base. So 2 to the 3 is the largest, 3 to the 1 is the largest, 5 to the 1 is the largest, 120 is your LCM, right? So that means what divides into that? Well, 60 does, and 120 does. 240 does not. Key word here is must divide into, not could. Could would be 1, 2, and 3, but must, you take the smallest possible value. That value is 120, so 1 and 2 is the answer here. All right, cool. So that's going to set us up for one more question, and then, like I said, we can chat a little bit. This is a cool question, so take your time here and give you guys a few minutes. All right, cool. Oh, this is good. A lot of you guys got this right. And I actually consider this a pretty hard question. Unless, of course, I'm looking at the answer from the previous one. Maybe I am. But in any case, we can talk about it. Any more answers rolling in for this one? All right. Did you guys recognize something I taught you earlier? That statement 1 gives us no relevant information based on the given information. All right, cool. Now, what's cool about that, and I kind of said this just not as formally before, once you know that, obviously A doesn't work and D doesn't work, but C also doesn't work. because you would never use the statements together. So you're really getting it down to a 50-50 shot here, which is pretty cool right off the bat. So if you have to do some guessing, well, your guessing is, going to be a 50-50 shot. Now, knowing that n is a multiple of 16 means the minimum value of n is 18. Knowing that m is a multiple of 30 and m is a multiple of 12 means we can use that information, as I just taught you, to get the LCM, right? Now, you can break into primes, but if you feel just comfortable with numbers in general, it probably shouldn't take you too long to see that the LCM is 60. I mean, the next multiple after 30 is 60. And if you've been doing the GMAT long enough, you probably already know that 12 times 5 is 60. So just a way to save a little bit of time. Then you plug this in, 18 by 60, divided by 120. Don't multiply 18 by 60 out. Just do some reducing. 2 goes into this 9 times. So is it an integer? Oops, pen tablet. The answer is yes, it is. And the answer is B, statement 2 alone. And that should be statement 2 works. Any questions about that? All right, cool. Well, we can end here. This was good, guys. I don't have any more questions, actually. So maybe next week we'll do more number properties. Some other divisibility and LCM stuff we can do next week. So maybe we can do that next week. But do you guys have any random questions now about your GMAT, about Target Test Prep, anything like that? I wouldn't say there's anything specific, but the thing is, there's not much to know about smart numbers. I mean, if you want to use a smart number with percents, you use 100. If you have fractions and you want to use a smart number, you use a number that is divisible by the denominators of your fractions. And that's really all there is to it with smart numbers. You're only going to use them in situations where you're trying to find either a ratio or a fraction or a percentage in the answer choice, because no matter what number you use, it should give you that. And that's kind of the long and short of smart numbers, to be honest. There's not like a ton more to even think about with those if you're talking about problem solving. Data sufficiency is a different story, because what you plug and when you plug is very dependent on the type of problem you're working with. And it's actually very few and far between, which is something I've taught a lot in these webinars. But yeah, I wouldn't say there's much more to it than that. Oh, good. You're finding our verbal course very useful. That's good to know. You're wondering how to increase your quant score using TTP. I mean, it depends on if you're really far off your goal, follow the exact course and do everything we say. If you're close to your goal, then, maybe you can be a little bit judicious about the things that you're reading deeply on in TTP, the things that you're skimming, but still following the study plan and being thorough where you need to be. And remember, the course is incredibly detailed and there's a lot to get through. But if you're already at like a 45 quant and need a 48, for example, yeah, I'm not going to expect you to sit there and read about adding and subtracting fractions for 3 hours. I would say you skim it and you move to the next thing. So yeah, that's how I would use TTP. By following the study plan, you know that you're checking the boxes of the things that you need to learn, rather than just jumping around and then hoping that you've kind of covered everything and filled in the holes. Let's see what else here. Remainders is possible, maybe doing a little bit more LCM, GCF, and then maybe remainders. Well, there's a ton of time-saving strategies on DS, but I think the first thing, and I teach this all the time, especially when we do the inequality webinars, is that you can't plug in real numbers or test all of these number cases when you don't need to. A lot of time, the problem can be done with simplification, or it can be done with substitution, things that you wouldn't expect that you can use. And so you got to get to a place where you're able to recognize those strategies, or seeing that there's a C trap, or, you know, part of the time it's just understanding the underlying concept in which the question is based on. Like, if there's a tricky unit digit pattern DS question and you understand unit digit patterns like the back of your hand, then you're going to crush that question. You're going to do it quick. So sometimes the time saving is just knowing your stuff cold. Yeah, we can do one on inequalities. Generally, the questions I give are high level for those. Geometry and coordinate geometry, like everything else, is really important. I mean, look, it's a 31 question quant test. No one knows what you're going to see, how often you're going to see it, so you just got to be prepared for everything. And if anyone tries to tell you that they know how many geometry and coordinate geometry questions you're going to see on your GMAT, they've lost their mind. Nobody knows the answer to that. If we did, this would be a much easier test. We would say, okay, well, I'm going to proportionately study for topics X, Y, and Z because I know I'll see them X% of the time, and that's just not the case. So just be prepared for those sections. Yes, you'll have weaknesses. That's part of the game, but, you know, try to have as few weaknesses as possible. Besides TTP, you could use the official guide if you wanted more questions to practice or any official problem sets. I mean, time management, we have a blog on it, but it's not like, you know, there's no secret sauce to just being quicker. It's A, knowing your stuff cold, which means you know how to attack questions, and B, not making sure that you feel overly comfortable every time you answer a question. And I said this previously in one of our DS questions here, where it was like, okay, you could understand that there's nothing to look at together, or you could overcompensate and, you know, be in a position where you're saying, well, I'm going to look at these together, even though I know I shouldn't. And what does that do? It eats up 30 seconds. And if every problem you're having to feel like extra safe that you got it right, then you're going to waste time. I mean, even 10 seconds on every question. If you waste 10 seconds on every question, double checking something, that's 310 seconds, right, throughout the quant section. So 310 seconds, if I'm doing the math right in my head, is about 5 minutes. 5 minutes. So there you go. I mean, within those 5 minutes, you could probably answer 3 of those 5 questions and then guess on 2. So, you know, just start thinking about that as your overall kind of macro timing strategy. All right, cool. So if there's no more questions, we can stop here. Like I said, next week we'll probably do some more number properties. If you guys need anything, reach out. We are around. And have a good week, everybody. Thanks for coming.